Hello, everyone. My name is Lorenzo Frattini. I'm excited to be here today. We will talk about Clayton and getting started with Clayton. Before we start, just a little introduction about the topic. We will discuss essentially topics related to Salesforce DevOps that involve security, code reviews, static code analysis, and what we will show what we're building at Clayton. At Clayton, we're building the first Git-based AI-powered code review assistant for Salesforce developers. So hopefully this will be an interesting session. We will try to keep it dynamic and interactive. Before we jump into the session, I would like to very quickly introduce myself. As I mentioned, I'm Lorenzo Frattini, founder of Clayton. My background in the Salesforce space is I started as a developer, eventually worked my way up until becoming a Salesforce certified technical architect, which was an amazing journey. Really enjoyed every minute of it. I am very passionate about the topics that we are going to discuss today. I can nerd out about these things for a very long time. Because I truly am very interested in the teams that we are going to discuss today, apart from doing that for a living. If you want to connect with me, you can connect on Twitter or on LinkedIn. I will be very happy to continue the conversation if that's something that you find interesting. But that's enough about me. So the agenda for today, the session that we prepared for you is really kind of an overview on the world of Salesforce development. Unlike probably the typical session that you're used to on this channel, we will kind of take a step back. This session will be pretty much looking at the big picture as far as we can share in terms of some trends and some of the findings, some of the lessons that we learned in doing what we do. We will also talk a little bit about static analysis. What is that and why do we need it? And then I will tell you a little bit more about Clayton and why we are building something in this space, what kind of the motivation is, what we are, our goal is in building this really cool piece of tech. And I will also show you Clayton in action. If you've seen Clayton already in the past, stay tuned because we will show you some very exciting new stuff that we are about to launch. And we will also show you how you can get started with Clayton. Hopefully all this stuff will be interesting and exciting if you're a Salesforce developer working on an org, or if you're doing this for yourself, or you're working on a product, or perhaps if you're building a product on this platform. By all means, stay tuned because hopefully we'll share some exciting and interesting stuff for you. So the first thing that I wanted to share is kind of a reflection, an overview on the code that we write. So Salesforce is big. We have a lot of developers working on this platform, writing a lot of code every day. It's a massive platform with a lot of traction in the development ecosystem as well. And what we do at Clayton is, we will show you this in a minute, we will talk about this, but what we do at Clayton is essentially we code review a lot of code. We scan it, we have a semi-automated, actually highly automated way of doing this and kind of addressing this matter. But in summary, what I wanted to share today is kind of a reflection on how good is the code that we write together as an ecosystem in this space. At Clayton, we scan roughly 2 billion lines of Salesforce code every day, not only Apex, but also Lightweb components, Visual Force, but also flows. I mean, we call it code, but it's really kind of code and metadata, code and configuration. And we scan a lot of it. And we can share our insights today on what we see on average, what are some of the patterns and the recurring mistakes that we see over and over again. And there are two important things, in my opinion, that are not very commonly discussed, but I generally believe these are very, very important problems. The first thing that I wanted to kind of play back is that on average, roughly 76% of the applications that we scan have live vulnerabilities in production. So their production code, it can be a product, an ISV product, or it could be a Salesforce org. But on average, we see a lot of vulnerabilities that are essentially deployed in production. Now, when we talk about vulnerabilities in the Salesforce space, we are talking about something that is kind of slightly different than what we have in typical web application, where vulnerabilities are a big deal and kind of something that every developer looks after and looks out for pretty much, constantly. In the Salesforce space, we don't see the same. There is almost this misconception that security is taken care of by us, by Salesforce for us, whilst in reality, there is a shared responsibility, and we as developers need to make sure that the code that we write, the solution that we write, are secure in the sense that the code isn't secure by default, and we need to build and develop with security in mind. And as far as we can tell, the vast majority of teams struggle to get this right. We can talk about the implications later, but I believe this is a very, very concerning figure. If you think that Salesforce as a platform contains, a company's most valuable information asset, data about customers, and potentially there are customer-facing elements to this, to every implementation we do with communities, or if we are building a product on this platform, this will be installed by customers in their orgs. It's so important to get security right, and we see that as a major kind of a pain point for teams. The second thing that I can share from what we see is that development costs are not as efficient as we want them to be. In general, 35% of the development costs that a company is spending on their developments on this platform are lost to technical debt on average. Now, what it means is that when we are writing some code and we leave something that isn't right, that we will go and fix later, we are adding technical debt. And what the problem with technical debt is that it makes you slow, and it's something that you have to kind of go back to and fix later. And there is a significant impact. If you think about, the scale of Salesforce deployment and how big is the services industry around development and the partner ecosystem, there are a lot of money that are being wasted to this problem. And so, first and foremost, there is a problem out there that can be addressed by writing better code. And the second thing that I wanted to share is actually a little bit more about the security of the code that we write. What are the most common vulnerabilities that we see? And so here I am collecting some, again, playing back some of the data that we have collected. There is by far the most common issue that we see is sharing violation in CRUD or FLS bypass. So these violations are essentially have to deal with how your Apex code doesn't enforce the security settings, the data visibility settings that your admin and architect have designed. So it's actually very common that developers will accidentally make this mistake. And in doing so, we are creating a potential route for data to be leaked outside. And this is particularly important if we have a community, for example, where external users are going to access the data in the org to some degree through some community customer-facing components. We also see issues such as SOQL and SOSL injection. Roughly one org out of 2 has this problem. Very, very common. This is potentially a problem that can be exploited by a bad actor to trick your solution and extract arbitrary data from it. So also very, very serious. And other issues are very, very common as well. Other security issues such as excessive data privileges, exposing sensitive information in the bug logs. So all these things are common because getting security right as a developer is tricky. And what's also tricky is if you think about all the things that a developer has to think about when we're building on the platform, suddenly security is yet another layer that we add on top of creating a solution that is robust and scalable and follows all the best practice. And of course, all this stuff is on top of the fact that we have to build the functionality for the business that does something that is written on a ticket, and we need to get it right. So a lot of this stuff, I think we are, what I wanted to say is that getting this stuff right isn't simple. It's very commonly done incorrectly. And I believe that the problem here is that we are fundamentally putting a lot of responsibility on the shoulder of the developers. And we are essentially, every time a Salesforce developer is hired and needs to kind of write some code, build the functionality for the business, we are asking them, yeah, deliver this functionality because it needs to do what's written in the ticket. And then 200 additional things that you have to get right, that no one will ever even see, but are part of how we are building this solution, how we are designing the solution. So all this stuff is difficult, it's tricky, and the data suggests that most teams don't do this properly. So how are Salesforce developers dealing with this? Now, of course, if you are an experienced Salesforce developer, some of these things will be absolutely, you will know this stuff already, but just to just for some clarity and kind of reviewing some of the key concepts, the key idea in general, the state of the art, is considered what's called the shift left model. So traditionally, and you will see in this chart, the traditional quality assurance model. So whenever we are building something, we want to make sure that it does what it's supposed to do, and the quality of what we've built is correct, spot on. If what we are building is a feature on the Salesforce platform, we want to make sure that all the acceptance criteria are addressed. The functionality does what it's supposed to do, but also follows all the various acceptance criteria that we need to fulfill. And this could be non-functional requirements around supporting scalability to large data volumes. So the code needs to be robust, and perhaps we need to make sure that there are a certain number of things that we do as part of that code. The code needs to be tested in a certain way. So there are a few things that go around, right? And in checking the quality of what we build, we want to validate that all these things apply. So traditionally, the quality assurance is something that is done late. So imagine that as a developer, you are building a functionality, you're then deploying these functionalities to some sort of testing environment where somebody is reviewing this, testing it, making sure it works, right? So this is what is the traditional quality assurance model means. And the test happens, most of the tests, they happen before, around the release. So there are some stages in the software development lifecycle. We go from plan and design to development, which is when a developer is writing code, and then we have a test phase and we have a deployment phase typically. And traditionally we will do things around that time, but the key idea is that we need to bring this forward as much as possible. All the tests that we need to do, all the validation that we need to do on our code, everything about it should be as much as possible shifted left. So as close as possible to the point of the, as early as possible in the development. So plan, design, develop, all this stuff works as long as we do it as early as we can. So the key idea, the golden standard here is that we should use source-driven development, the key, and a lot of techniques to try to essentially fail early. If there is something wrong in our code, we want to figure that out as quickly as possible. And that's kind of the goal. So how do we achieve that? Essentially is by automating everything that we can automate. Okay, so that's why it's important about talking about these things. Of course, you can build a solution without shifting left, and most teams, maybe not most of them, but many teams are still doing this. And if you're a small team, you can probably get away with it. But if you're working at a certain scale of complexity or a certain size of the team, these are very, very important things that you should be doing. And so the idea is shifting left. Now, the code validation, to validate code and validate the kind of problems that we have discussed earlier, for example, security. If we want to make sure that the code that we're writing is secure, the traditional way, of course, is do what's called a code review. The key idea of a code review is having someone else looking after a code that we have written. Someone else can be another person. In those cases, we talk about over the shoulder or peer reviews, or it could be a tool. So we call about a tool assisted code reviews. But the key idea of a code review is everything that I have written, I want this to be validated and checked by someone or something else, so that I can find the bugs early and fail early, as we said a minute ago. This overall idea is actually extremely powerful and works very, very well in making, in finding bugs early, in improving the overall quality and security of the code that we write, and also in reducing that technical debt that we mentioned earlier. There is another very, very important side effect of code reviews, which is one of the reasons I'm such a big fan of this process. Of course, we do this all the time in Clayton. I personally do code reviews. I keep doing that. Is the fact that we share knowledge in doing so. So as we do this kind of review, combining to a certain degree automation and to a certain degree the human factor, we are creating a kind of a positive loop where we can share important knowledge. Okay, this is extremely powerful, works very, very well. However, there are a few things that don't work well in code reviews, especially when we do them with another person. The typical joke here is that if you have done a code review, you can certainly you have experienced this. When you are asking someone else to review your code and your change is tiny, they will have a few comments and a few pointers. But the bigger is the code that you have to review, the most unlikely is that someone else will find problems. So we're kind of there is this kind of joke that, you know, if you have a large code review, it will almost every time pass without flagging any issues. But of course, this is not this is one of the issues of code reviews when done manually. You're looking at a task that is highly repetitive. You're interrupting someone else to kind of get feedback on your code. The feedback that needs to be provided is probably looking, the person that is providing the feedback is probably looking at a checklist, or from experience doing it from the top of his head or their head. And they're probably going through always the same things over and over and try to validate a few points, a few criteria that are highly repetitive. There are some code reviews out there. There is a fantastic article on Apex Hours, but you can find some very good code review checklists that are written for Salesforce developers. And you will see that they are big. There are a lot of things that you have to check. And it's very unlikely that every change can be validated in this way. In practice, it's not very scalable. It's a great idea, has a lot of value, but in reality, it's hardly done right. And there are very good reasons for it. And also something that is very specific to Salesforce is the fact that very often when we build something in Salesforce, yeah, sometimes we use code and that's fine. But when we use configuration, most of this configuration is expressed as XML, and XML is extremely verbose. So if we make a change to a flow, let's say we add a path to a flow, that can be hundreds of lines of XML. Just, kind of a relatively straightforward change becomes suddenly a very big code change that some human will have to review. And that's, of course, is when things start to go wrong. And that's why I believe we start seeing a lot of these issues in the real world. And because although code reviews are great, most people take shortcuts or don't do them as they should because of many reasons. Pressure to ship, the fact that they are huge. It's not fun to read XML with your eye. So this is really not about pointing fingers or blaming people. It's really, from my standpoint, is acknowledging that this stuff is hard, and a lot of people aren't doing it well because there are some objective barriers to it. So, okay, we talked about code reviews. We said that humans can do code reviews, but what about tools? Well, of course, tools can help. The field that tries to address this problem is called, the typical approach to this problem is called static analysis or static code analysis or program analysis. And the key idea is that we can use some sort of tool that can reason about the program and find certain problems without executing the program itself. Okay, so imagine when you review code that is being written by someone else. What you're doing is probably you're reading the code on your screen. Perhaps you're kind of following what the code does. I do it with kind of my finger on the screen because I'm an old guy, but also because kind of there is a flow to the code. And when a human reviews some code, it tries to reason and anticipate what the code will do without executing it, typically. Of course, you can try things out, but the key idea of static analysis is let's take execution on the side. Let's not worry about it. What can we tell about this code just looking at it? And this is great. This is very powerful to detect bug and security flaws. Very useful, as we mentioned with code reviews, because we want to fail early. We want to catch bugs early. And if you want to look at static analysis tools that exist out there, there are some very well-known open source tools in the Salesforce space, such as Apex PMD. Salesforce is doing a very good job, in my view, with the code analyzer. They are trying to push a little bit kind of the envelope of what's possible, and kind of contributing some open source tools to this space. So if you are developers, you're starting out, you've never looked into this, by all means, you should kind of check what's available out there. And all these tools help with code reviews. The kind of the challenge that we see, and I personally, as a Salesforce architect, I've always been kind of frustrated about, is that despite being helpful, these tools are very often inaccurate. So on average, now it depends on what you're trying to do, and there are very technical reasons why this happens. But as a developer or as an architect, you just want to kind of ship code, you want it to be done right, you want it to be vulnerability free. You just want to focus on building and shipping. The tools that are supposed to help you in this, they produce a lot of noise. And that, of course, is absolutely not great for developer productivity. Another issue is that they don't cover Salesforce well. So most of the tools essentially have been ported by most cases from Java technology or the JavaScript space. And what they end up doing is approximating a lot of the issues that they are looking for. And there are some nuances, though, about Salesforce development and how code is represented in Salesforce in the form of metadata that these tools don't understand. And so if you want to scan an entire application, enterprise application, you need to start thinking about, okay, what's covered by these tools? Because anything that the tool cannot catch, we will have to review manually. And if you start looking at the spectrum of metadata, you will see that only tiny portions of it are supported. And this is true for open source and commercial tools alike. And the other problem is that the tools cannot fix your code. So this is also something that every developer at some point have seen. So you run the tool, you find, thousands of issues. Most of them might be noise, but those that are true, how can you fix them quickly? Well, not so easy. And I was personally always found this very, very kind of frustrating, because as a developer, and if you want to kind of look for the optimal agility that a team can have, you want to make sure that all the repetitive stuff is automated as much as possible. So although static analysis helps a lot, there are still some fundamental issues that the bigger the code, the bigger the team, the more painful these issues are. And these are essentially remaining with a lot of noise. So if you have a lot of noise, the developers will still have to kind of scan their code manually, doing a lot of repetitive triage to distinguish the noise from the cool stuff. Also, you have to do a lot of manual review for all the stuff that is not covered by the static analysis tool. So kind of a typical example is you build flows are not covered by the static analysis tool. Therefore, you need to review those flows manually, but they are XML. And so they're huge, not fun to review. And then, as we mentioned, the developers remain with the fixes that are repetitive. So all this to say that although the technology that is there does something and helps, I believe that as an architect, I believe that, there is still too much that we're asking developers, and there is too much responsibility on their shoulders. And if you take into account the fact that they are pressured by the business to ship code that works and solution, then you quickly see why those numbers that we see are, after all, what we see in the real world. There is so much for teams to kind of do, and you have to cut corners, because even if you don't want to do that, things will slip through the cracks when all this pressure is completely down to the devs. And so this is essentially what motivated me to build Clayton. What we're building at Clayton is the first Git-based AI-powered code review assistant for Salesforce engineering teams. So what we take is something that I like to say this. We start from what was done with static analysis, and we say, okay, can we do more? Can we take this one step further? Can we push kind of what's possible to automate even further? And So what Clayton does that for us is kind of a goal is essentially 4 things. First, we are building a tool that is built into Git. Creating a tool that is built into Git is essentially to make sure that developers can forget about it and just get on with their day and write what they want to write, which is, code. The second thing that we do differently is that we don't just use static analysis. We combine static analysis and AI to understand the code with the highest possible precision and to generate fixes automatically. So this is a big deal for us because, and for me in particular, because I'm really passionate about pushing the envelope of kind of what's possible to automate. Instead of creating tools that can tell me, here's a problem, and I have a 50% confidence that that is true, how can I push that to be as close to 100% as possible? That's why we're kind of taking this completely new approach, which combines AI and static analysis. The third thing that we are kind of passionate about is providing insights. So collecting data and help teams use this data to improve and to learn. I love using data. I'm a kind of a data nerd, and being data driven, I think, is something that adds so much value to every team that we really wanted this to be kind of a core tenet of what we're doing. And the other thing that we want to do that is very important for us is to cover everything. So we are building an assistant that is not only works without changing how developers work, is intelligent and can fix the code, but also covers everything that matters. All the 200 plus metadata types that exist in the Salesforce, coverage report, can we support them all? So that's a very, very big goal for us. And so all these things are defining what Clayton is. So we will show Clayton in action soon enough, but how does it work? So Clayton is a commercial product, is a software as a service, or runs in the cloud. We will show you how you can get started. There is a free developer edition that we are launching right now. So you can use this for free on your personal projects. And of course, there is a commercial licensing for teams that want to use this in their professional developments. But if you want to get started for free, you can go on our website, getclayton.com, or you can go on the GitHub Marketplace and search Clayton, and you will find essentially our GitHub app, and you can get started from there. Okay, so I think this is a good time to show you how Clayton works and what it looks like. So let me do it. Okay, so Clayton is a code review assistant that works in Git. So I thought the best way to show you how to get started is by taking a repo and creating a fork so that we can show you how Clayton works, essentially. The key idea is that so if you think about, imagine that is your first day on the job, you're starting working on a new project, and it's okay. We have just connected our Clayton account to this Git repo. What I wanted to show you is that as soon as you connect the repo of your application, Clayton starts producing a visual report of the security and the health of this code base. So what we can see here is, for example, an overall score, technical debt ratio, which is a measurement of how much it will take to rework versus rebuild from scratch, essentially. We'll also give us kind of a summary of the issues and how long it will take to fix them, and a comparison of this application to the benchmark, how other teams are doing. Is this code kind of any better, any worse? And here we can see that there are some issues. Interesting issues around security. So we can see that there is a bunch of CRUD-FLS violation, some hardwire parameters. Let's have a look at that. So here we can see that 11 CRUD-FLS violations were detected. Here we can see what a CRUD-FLS violation is, if you are not familiar with the issue. This example, we can even see where the issue is in the code base. Now, what I'm using here is just a sample application from, it's a sample showcase application to showcase kind of the general aspect of an application. By no means this is intended to be a production-ready application, but just for what I wanted to show you is what happens when you connect your Salesforce application, which is in a Git repo, to Clayton. You will get automatically this report generated that will help you make sense of what's the state of the code health of the application, the security of the application very, very quickly. So we can zoom into all the various issues, see where the issues are in the code, and essentially this overview will be automatically updated as the code evolves over time. Okay, let's take a look at how Clayton can review code automatically by monitoring what's happening in our GitHub repo. So I'm a Salesforce developer, I'm working on a new feature, and let's just start working on a new branch from main, and we will call this my demo feature. And let's create this branch, and let's create some code for this feature. As you can see, I'm very, very quick at writing code. So let's assume that this is done, tested. I'm super happy with this functionality. I will say that added geocoding feature, and I will commit this change and push it on my origin branch. So this is what a developer should do when they're done with developing an application. Now, good teams have a definition of done that essentially helps the developer thinking about all the things that need to happen before the code is ready. But let's say that we open the pull request here. Let's open a pull request toward the main branch from my feature branch, and I create a pull request. Now, a good habit here is to describe what the pull request does. So, for example, this is my new amazing geocoding feature customer that allows customers to locate themselves on a map, whatever. And this is my Jira link, and I will paste the link. And this is another very good thing, which is having a code review checklist here. So I will add simply, I will go through this checklist. This is something that I would encourage everyone to do. Have a checklist in your email pull request template that tells you, that helps every developer goes through all the mental steps that need to be done before a feature is finalized. And what we see is that just by creating the pull request and submitting it for review, the bot has reviewed it. And what the bot has spotted here is that the developer has accidentally removed the sharing, which is a problem because from a security standpoint, that means that this code, which is accessing the database, is not enforcing the correct sharing. And so the bot itself is requesting that the developer make some change, and we can even set up things in such a way that this merge pull request button is not available, and we can physically prevent the code from being promoted further just because it has a vulnerability in it, or in this case, a security misconfiguration, something has been overlooked that could actually make the code insecure to a certain degree. So, of course, we don't want that to happen, and we can prevent the development. Now, at this point, the developer can simply rework the story, but what I want to show is that the bot itself is clever enough to review and make some suggestions automatically. And this is such a cool feature. I'm super excited about this because what Clayton is doing here is that Clayton is automatically figuring out that yes, there was a mistake, but the fix is simple enough. So I will automatically suggest the developer to make this change. And so as you can see, the bot is creating the change, has created the pull request, and is saying, I suggest you add this to the developer. And the developer is actually tagged as a reviewer automatically. So I will receive an email if I'm not here. And all I have to do here is merge a pull request into my branch. And if I go back in my code here, I can see the change. And as you see, my code is now has been improved by Clayton. So that's it. That's how Clayton will review the code in a pull request and flag any issue, in this case security, and if possible, even make a suggestion on how to fix the issue. I will now show you a demo of Clayton's latest AI-based auto-fix. In this example, I'm a developer writing unit tests in my Salesforce application, and let me open my VS Code and write some amazing unit tests. As you can see, I'm very fast at typing. I will also very rapidly committing more tests for our amazing app. I will commit and push all these changes to my repo, which is what every good developer should be doing. Now, what is now going to happen is that Clayton, which is a bot that is built into Git, will automatically react to the proposed development, the proposed changes by the developer, and is looking for things that can be improved. And in that case, the code is fine, the tests are fine, but the developer didn't include assertions in the code they have written. I haven't. So let's give it a couple of minutes because I'm doing everything live. Okay, and as you see, Clayton is creating a pull request automatically. So the bot is making some suggestions here. And what the bot is suggesting is that I add a few comments here to my tests. I'm adding a comment, as you can see, comments to all the assertion. The code change makes sense because it's meant to improve the quality of the code. And as you can see, Clayton is using AI here to generate some meaningful comments for these assertions and making formally correct changes in the form of the pull request. So as a developer, all I have to do is to review these comments. And if I'm happy with them, accept them into my branch. And there you have it. That's how Clayton can help you make your code better. There you go.